In this video, we continue here with exponents and we want to look at finding the roots using prime factors. So in some questions, under the root, you might have a very big number. And when you have a big number under the roots, you want to write the number as a product, meaning times, product of their prime factors in order for you to solve the roots without a calculator. So in this question, we have some examples here, and we have in question number 1, the square root of 225. So 225 is kind of a big number. It's a big number there. So let's say we don't know what that answer to is. So we're gonna take our calculator and you're gonna say 225 and then we say equals and then you say shift and then you look for this button with the commas there. On top of it, it has that fact. So that's what you're looking for, the fact. So then when you press that, it says 3 to the power of 2 times 5 to the power of 2. So that means that 225 can be rewritten as this. And then you come back here, you say, well, I have the square root of actually 3 to the power of 2 times 5 to the power of 2. Because that's how you can rewrite that. And then you say, well, the square root of all these bases, right? That's what you're looking for. So the square root of 3 to the power of 2 will be 3. And the square root times the square root of 5 to the power of 2 will be 5. And then 3 times 5 is 15. So what did we do here? We took this 225, we put it in a calculator, and it gave us that. So that's the product of the prime factors that we were talking about there at the top. So we wrote that as prime factors so that we can be able to work this out easier. All right, so the square root of 225 is 15. So let's look at another example here on the next side here. On this side, we definitely have the cube root that we're working with here. So all right, this is equal to the cube root of. Right, we need to write this as a product of its prime factors, and the best way to do that is actually to use our calculator. So let's type in 9261, and then you say equals, and then you go shift, and then this gives us 3 to the power of 3 times 7 to the power of 3. So we want to come back and write 3 to the power of 3 times 7 to the power of 3, and we know that the cube root, remember to put your 3 here, because if you don't, then it's wrong. The cube root of 3 to the power of 3 is 3. The cube root of 7 to the power of 3 is 7, and then this gives us 21. Because guys, remember, how do I know that the cube root of 3 to the power of 3 is 3? I know that 3 cube is a cube number formed by a 3 times a 3 times a 3. So the cube root of this one will be one of the numbers that multiply itself to give you this number. So in this case, we have 3. As well with the 7, 7 times 7 times 7 is 7 to the power of 3. So that means that the cube root of 7 to the power of 3 is 7. Now let's practice more questions and more situations whereby you got a big number, but you do know the square root of the smaller number here, the 4. We do know what the square root of the 4 is. So we can just write it out as 2. So the square root of 4 is 2. And then when you have zeros, just pay attention to the zeros. If you have 2 zeros, you gotta take out one of them. So the square root of 400 is 20. Another way you could have done it, you could have said, well, let's find another way to write down 400. And then you use your calculator there. And in your calculator, you're going to type in 400 equals shift, and then you get this 2 to the power of 4 times 5 to the power of 2. So this becomes 2 to the power of 4 times 5 to the power of 2. And we all know that 2 to the power of 4, the square root of 2 to the power of 4. Remember, you're looking for the square root of the bases. You got 2 bases and you need the square root of 2 to the power of 4 will be 2 to the power of 2. Because 2 to the power of 2 times 2 to the power of 2 is 2 to the power of 4. Times 5 for here, which is 5 to the power of 2, is the square root of that is 5. So this becomes 4 times 5. So the answer is 25. So that's another way you could have done it. What I'm showing here is a shortcut if you have a square root and 2 zeros. If you have a square root and we know the square root of this digit, so these 3 digits, which is 100. So the square root of 100 is going to be 10. But because we have 2 extra zeros there, we have to take out one of them. So the square root of 10,000 is 100. And then let's go over here. If you have a cube root, you might know the cube root of 27 is 3. But because you got 3 zeros there, you gotta take out one of them. So 30. So 30 times, that means 30 times 30 times another 30. 30 times 30 times another 30 is gonna give us this, because 3 times 3 times 3 is 27, and then you have to add these 3 zeros there. See? Right. And then over here we go, we know what the cube root of 125 is. It is 5. And then if you got these 3 zeros here, you gotta take out one of them, and this becomes 50, because 50 times 50 times 50 is 125,000. Right, so that's how you can deal with these problems over there, guys. It's very important that you see how to deal with that those problems there. And now we want to go over to the next part. Let's practice this one as well. Again, we have a square root over here. Square root of the fraction at the top. So the square root of 81 is 9. And then because we got 2 zeros here, take out one of them and share them to the 9. So we got 90 at the top. Now at the bottom, we know the square root of 100. The square root of 100 is going to be 10. Now because you got 2 zeros there, it's under a square root, you take out one of them, so it's 100. So it's 90 over 100. And we all know 90 over 100 can be simplified to 9 over 10. And this question over here, we got the square root of x to the power of 90 over y to the power of 100. So again, you want to ask yourself, what number can I times x? What number can I times by itself to give us x to the power of 90? What about x to the power of 49, which is half of 90? X to the power of 45 times x to the power of 45. That means that I will have to add those exponents, right? I would need to say 45 plus 45 plus 45, that gives us 90. So we know this becomes x to the power of 90. So the square root of x to the power of 90 is x to the power of 45. Similarly, we can find this is y to the power of 50, because y to the power of 50 times y to the power of 50 is y to the power of 100. Now over here, in this question, again, there aren't any zeros here, so we probably have to write this as the product of their prime factors. So let's rewrite the sum, right? I'll say this is the cube root of. Now, here at the top, let's just put it in. We have 2744 equals shift. Now this is 2 to the power of 3 and 7 to the power of 3. So 2 to the power of 3 and 7 to the power of 3. So that's what we have there at the top. That number changes to this. Now at the bottom, we got 5,822. We say equals shift, and then we get 5,000. I don't believe I wanted to use this one, because then it's not going to work out nicely for us. 5,822 equals shift, and then do that. Okay, so if we go shift, it does not give us a nice answer, but let's work with this, because in the exam you can get something that does not work nicely. So this becomes 5 let's do it. 522 equals shift, and then you get this, and then you have to write it down. So this is 2 times 4 1 times 7 1. So that's how our sum looks like, right? Now you need to get your answers here. So 41 and 71, they are probably prime numbers, so there's nothing you can do with them. So the cube root of 2 to the power of 3, we know the cube root of that is going to be 2. And the cube root of 7 to the power of 3 is going to be 7. So those are out of the root now. So this is 2 times 7 over. Here at the bottom, there's nothing you can do with that. So we have to write it under the root. So it's cube root of 2 times 4, 1 times 7, 1. Because in other words, they can't make it out of the root because you won't be able to find the number that can times itself to actually give you 2. No number can times itself to give you 2, right? So that's the problem there. No number can times itself to give you 41 or 71. So if I rewrite it very nicely for you, 2 times 2 is 14. So this becomes 14 over the cube root of, let's just combine 2 times 41 times 71 back to 5,822. So that's the only thing you can do. You can take out the fraction at the top out of the cube root, but here at the bottom, that denominator unfortunately does not make it out of the cube root, so you have to write it as under the cube root. That's a possibility. You must understand it can happen. Okay, so now let's go to the next question over here, whereby we have, now in our calculator we check what is 3,375. 3375 equals shift. So if you rewrite that, it becomes 3 to the power of 3 times 5 to the power of 3. And then you want to check what is 42,875 in the calculator. So you write 42875 equals, and then you say shift, and then it becomes 5 to the power of 3 times 7 to the power of 3. Now I want to shift your attention to this. These guys are actually the same, and we had ones that are the same there, but I wanted to do something different here. So because this and this, okay, just forget what I said here. 2 to the power of 3 and 2, they are not the same. Okay, they are not the same. Just forget about that, and let's just scratch that out. So I want you guys to understand that if you have a 5 to the power of 3 above the division line and you got a 5 to the power of 3 below the division line and everything is just timesing there, you can just cancel these. So these guys go bye-bye because they are the same. It's the same thing as if you have 2 over 2, they cancel and they give you 1. If you had x squared over x squared, they will cancel and give you 1. So that's the same situation over here, right? You want to cancel those, so let's rewrite this cube root. So we write cube root of 3 to the power of 3 over 7 to the power of 3. So that is what we have now after those cancelled. And then now we work out what is the cube root of 3 to the power of 3. That's 3. The cube root of 7 to the power of 3, and it's going to give us 7. So this is our answer here. Yeah, so these just need a little bit of practice, but I promise you guys, you'll be able to get it once you start to practice. And you can try out the questions before I do in order for you to see if you understand how it needs to be done. Right, so what I also want to emphasize with this problem here is that you can actually simplify what's inside the root before you take it out of the root. So in this situation, we got 16. So always sign number letter. You always check the signs, and then you look for the numbers, and then the letters one by one. So the signs, I mean, like, is there a positive there or a negative? So they're both positive. A positive divided by a positive is still a positive. We're good there. But then a 16 divided by 8, that is a 2. That is 2. And then you got x to the power 4 divided by x to the power of 2. You should know now that you need to subtract those exponents because the bases are the same. They divide. You subtract those exponents. So what is 4 minus 2? It's 2. Now this one, again, you should now be able to identify that these guys are the same. So they cancel out. So there's no y squared anymore. So I have 2x squared to work with over here. The square root of 2 is something that I can't take out of the root, so I will just leave it inside the root. But x squared is x. The square root of x squared is x. So because I know the square root of it, it comes out of the root. So something like this is a possibility, is what I'm trying to emphasize to you guys. Something like that is a possibility. All right, so here we got that x. We got an x there. Yeah, it is the last question, but it's not supposed to be x. It's supposed to be a 3. All right, so let's deal with this. Now we got this big number and letters, and it's just a nightmare of a sum, right? But it's not. Let's make it simple for ourselves. The way you do this, you write the cube root of that, and let's see if those numbers can actually change. If those numbers can change, then we can be able to solve for this. So make sure you see it. Now I'm just gonna put this in the calculator, and I'll put 115 in the calculator. Just want you to see with me as well. Okay, 115 7625 equals to, shift, press that, it becomes 3 to, okay, let me just write it a bit neater here. It becomes 3 to the power of 3 times 5 to the power of 3 times 7 to the power of 3, x to the power of 9, y to the power of 15. I have to keep on writing that all over. Now let's do the one at the bottom. And I know that we have done this before. 42,875 equals, shift. Then you can see it's 5 to the power of 3. So we write down 5 to the power of 3 times 7 to the power of 3, x to the power of 6, y to the power of 6. Now we can simplify. It looks like a mess, but you need to look at all your bases. This is a base, that is a base, that's a base, that's a base, that's a base. Base, 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 base. All the bases that are actually the same will need to cancel out. This is a 5 to the power of 3, 5 to the power of 3, bye-bye. 7 to the power of 3, 7 to the power of 3, bye-bye. And these they have the same bases, so I need to subtract these exponents. So that's what I need to deal with right now, right? So let's still leave it under the square root. Let's put it under the square root still, the cube root, I mean. Let's put it under the cube root, and we say, well, we still have a 3 to the power of 3 at the top. These guys, bye-bye. These guys, bye-bye, because they are the same. One is in the numerator, one is in the denominator. Now we're going to have a base of x to the power of 9 minus 6, which is 3. The base of y to the power of 15 minus 6. So we go 15 minus 6 is going to give us, is it 9? So that gives us 9. Now we have something like this, and this is a bit easier because the cube root of 3 to the power of 3 is 3. The cube root of x to the power of 3 is x. The cube root of y to the power of 9 is y to the power of 3, because y to the power of 3 times another y to the power of 3 times another y to the power of 3 is going to give us y to the power of 9. So the cube root of y to the power of 9 is y to the power of 3. And that's it for this video, guys. I hope you enjoyed. I'll see you in the next one.